Hello and welcome to the first episode of this series in which I'll be doing code walkthroughs for projects. In this video I'll be going through step by step how to build the classic snake game in Java. This does have some pre-required knowledge though, so follow the links in the description to watch my free Java course for absolute beginners here on YouTube, or click on the card on screen now. The pre-required knowledge is an understanding of classes and objects, and everything that comes before that. My beginner's course covers everything you need to know. If you already have that knowledge, then welcome and enjoy the ride. This video will take you from nothing to creating a snake game using nothing but Java with different colour schemes available. It's a great opportunity to test the skills you have learned over the beginner's course or to deepen already obtained knowledge. The project itself uses no external libraries or frameworks and relies solely on what can be found within the JDK. This is just the first, most basic project I'll be doing. Subscribe to make sure you don't miss out on future code walkthroughs on more complex projects. Let's dive right into it. So the first thing we want to do is set up a new project in IntelliJ or whatever your desired IDE is. So here we have a brand new project. I've called it Snake YouTube. Doesn't really matter what you call it. Call it whatever you want. And we are in the main file. What we're going to do first is we are going to create a JFrame. A JFrame comes from the Java Swing package, which is a GUI package that's available in all distributions of Java. So everyone should be able to use this. Essentially, JFrames just create a window for us. We then attach panels, and panels are components that can contain other components, and that's how you kind of build up the application. If you have any kind of queries about JFrames, feel free to look them up online. There's plenty of information. I will go through the other components as we get to them, and a bit about how they work together. I'm going to start off here by writing some code to describe how large the window might be. So private static final int, call that window width equals 800, private static final height, int window height equals 640. You can make these sizes whatever you want. I think this is good. Later on, when we have a scaling factor, keep that in mind with your width and height, and you'll see what I mean later, but just bear that in mind. And then creating the JFrame itself, so we need a private static final JFrame frame equals new JFrame. We'll call this snake, like so. That'll just set the title to snake on our window. And then in our main function here, we just want to display that. So do frame.set resizable false. So I don't want it to be resizable just now. Frame.set default close operation jframe.exit on close. What this does is when you click the X button on the window, it will close the entire program, not just the JFrame, because if you don't have that, program will continue running in the background, which is fairly annoying. Then we need frame.set size. We can say window width, window height, and that's it. Frame.set visible true, like so. Now if we hit run, we should be able to see a window pop up. There we are. It does say snake on the title. My recording software won't show you the title. If I bring it across here, you can probably see snake at the top there. But I've kept it all on one screen, so it's easier for you guys, but you won't be able to see the title at the minute. But if I click the X in the top right, it exits off. Perfect. The next section we need to do will be the panel that's going to attach to this frame. This will be our main panel. it is possible to use other panels for like different screens and things like that. That's more advanced. We won't be doing it in this particular project, but if it's requested enough, I'll do it in another project. So we're going to go ahead and create another Java class here. I'm going to call this game engine because this is where most of our logic's going to go. And this game engine needs to actually extend JPanel. So JPanel, like so. And the reason for all that is we can then attach this to our JFrame. So in here, we need to kind of describe how big this panel is going to be. It realistically needs to be as big as the JFrame. So if we create a constructor here, game engine, int window width, int window height, like so. We actually need to store them variables somewhere, so what we are going to do is if we do private int window width, like so, private int window height, like so, and then we can say this, we are going to set this as focusable as well. What that means is if you don't set it as focusable, it can have issues later on with things like input. So don't want to get caught out on that. And request focus means this will always be the focus of all the panels, which we only have one, so we want that to be the case anyway. Then I'm going to set the two variables we just took in. So window width equals window width. Again, if you don't understand any of this kind of syntax, please go ahead and watch my Learn Java for Complete Beginner series, because it will go through all of this and it will all make complete sense to you. Window height, that is a capital W. There we are. So what needs to happen now then is we need to implement a method from the JPanel. I think it's actually from the JComponent actually that we've inherited from, and that is a method called public void paint. Oops. And what that's going to do is it's going to allow us to paint some graphics on the screen. Why do we want to do that? Well, later on we're going to be painting the background, the snake, the reward, those kind of things. But for now, we just kind of want to make sure that this panel gets attached to our JFrame correctly. So to do that, we're just going to draw a square. So we need to take in a graphics G here. So, and then we can say like g.setColor, color.black, and then we are going to g.drawRect 100, 100, 100, 100. So at position X 100 and Y 100, it's going to draw basically a square. I know it says rect there, but exact same things here. That is a square. So it should draw a black square, 100 by 100 pixels. So this won't work just yet. We need to actually add this panel to the frame. So we'll go back into our main class here. We then need to instantiate the game engine object. So private static game engine, call that engine. Let's call it game engine for completeness. Equals new game engine, and if you remember, it takes in the width and height, so pass those two in just there, and then we can in here frame.get content pane.add, and then we want to add the game engine in. What that will do, hopefully, when we click run, is we're expecting a black square to pop up, and it should be 100 by 100 pixels. It should be easily visible, and if that happens, we know that this panel is now attached to the JFrame correctly. Let's go ahead and run that then. Run main. There we are. And yep, as you can see, the black square is there, so that has been successful. Okay, so the next thing we need to actually think about now is the background of our game. So if you imagine, let me get paint paint up here. Sorry, I'm using paint, it's kind of ridiculous, but I'll just get that up so you guys can see it. Here we are. So if you imagine we have our game screen like this, the thing is, if we don't set out the fact that this is divided up into many squares, it won't quite work, and pixels will be off, and it won't line up correctly. It won't be the classic snake game we know. Your snake will be able to be like here, even though your reward's within a square like so. This is really hard to do, but you'll be able to like not be in the square, if that makes sense. So we want to kind of like snap the snake into a square. It's either in a square or in that square or in that square or in that square, and the rest of its body is in the squares behind it. So we need to actually split this background up into many different squares. Now to do that, we're going to have to do some calculations, and this is like I said earlier with with this window height and window width. You can make this anything as long as it's divisible by the scale. Now you'll see what I mean by the scale soon. I use a scale of 40 and make these divisible by that, so 800 is and 640 is. If you want to use 1000 and 700 and make it divisible by 10, and your scale wants to be 10, that's completely fine too. You will see what I mean later on. But to do that, firstly we need to create a new object. So Java class, we're going to call this one tile. Now all this object's going to hold is just some information about where the squares are. So each square is going to be broken down into something called a tile, and that tile will hold information about said square. So we do need a couple of things in here. We need the x coordinate. We need its y coordinate. Like so. And we're going to have a constructor to just kind of instantiate it. So int x, int y. Public tile. What am I doing? Public tile. And then this dot x coord equals x. This dot y coord equals y. And then we can do some getters for these things. Little trick, if you haven't seen it before, you can right click generate getter and you can select both of them in there and it will populate that for you, saves you typing that out. It's a really nice feature. Now that we have that set up in the game engine here, we need to instantiate all of those. So how are we going to do that? So firstly we need to come up with a list of tiles. We'll call that map tiles. This is probably the wrong type of list. Yes, it is. It's list from utility. List from util, not list from AWT. There we are. So we have a list of map tiles here, and then to kind of to work out where each of the coordinates of those tiles are, we're going to create a function. So that function it's going to be private. It's going to be a list of tiles on the return, and we're going to call that calc tile chords, like so. It's going to take in your width and your height. You can pass in a scale if you want, but you can also just define it in here. I'm just going to define it in here, which should be fine, I think. So yeah, I'm just going to define scale in here and then use it locally. Okay, so to define the scale, like I said, mine's going to be 40. So going back to that paint example, each box is going to be 40 by 40 pixels, if that makes sense. If your scale is not, if your width and height is not divisible by your scale, some of it will either be off the screen or it won't reach the edge of the screen properly. So you need to be really vigilant with this. So as long as your width and height is divisible by your scale, you're fine. Okay, so var x chords equals width divided by height. Var y chords equals width. Sorry, what am I doing? It's not width divided by height, it's width divided by scale. Sorry, height divided by by scale. So what this is going to give us is two numbers basically. How many boxes there can be across and how many boxes there can be up and down. So for example, width, we have 800 divided by scale, that's 20, scale's 40, so that's 20 boxes that can have. So x chords will equal 20. And you'll see how we're going to use that in just a second. Okay, so we need to create a variable that we can return. Tiles equals new array list, an empty array list like so, and then we're just going to populate that with a couple of for loops. So we're going to write a nested for statement here, for loop, sorry, for I, for int I equals 0, I is less than x chords, x chords minus 1, because everything starts at 0, and I plus plus, I plus plus, and then in here we are going to have another one that's the exact same but for y chords. Int j equals 0, j is less than y chords minus 1, j plus plus, oops, not equals equals, and not a capital J either, j plus plus. Okay, so in this nested statement here, we're going to do tiles, which is this list here. We're going to add, we're going to create a new tile, and that is going to be I times scale and j times scale. Now, I'll do a quick explanation of what's going on here so you're not too confused. Let's just return tiles here. Cool. Okay, so just so you're not so confused as to what's going on here, the logic at work. So I is 0, j is 0. So x here is going to be 0, and y here is going to be 0. When I is 0 and j is 1, though, that's going to be 0, 40, then 0, 80, then 0, 120, and it will start placing squares 40 apart at each of those coordinates, and so on and so forth, and it will do that for everything on the screen. It's quite a common way to do something like this. So yeah, if you need to just kind of like break that down yourself and kind of go through it, then be my guest, but that is how we're going to break this down. Next we can then assign our map tiles. So if we say map tiles equals calc tile chords and then window width and window height, like so, that should give us a list of tiles that we can work with. So why is that important? Well, in here, in our paint method, we can just go through all those and create a background using those coordinates. So if we do a for loop like so, for tile in map tiles, do this. So we're going to say g dot draw fill rect. Fill rect fills the rectangle rather than just draws the outline. So we're going to do fill rect. In fact, let's just for a visual representation, let's do a draw rect, and you can see each individual tile as it is, and then tile dot get x chord, tile dot get y, tile dot get y chord. And each one's going to be 40 big, which kind of is tempting me to put scale as a constant at the top here. Private static final int scale equals 40. Nice. Okay, and then we can do scale, and scale in here. Sorry, I had suspicions of doing this earlier, but here we are, changing all that to the constant. There we are. So what this should do is, we actually need to set the color as well. G dot set color dot, let's just say black for now. So what should happen here? It should just draw a bunch of black squares. So if I go ahead and click run now, as you can see, there are lots and lots of black squares on my screen, that is the kind of grid that the snake will work within. And yeah, that's how we've kind of broke it down now. So the snake won't go in between the lines. It won't be like 84 pixels by like 72 pixels. It'll always be in a multiple of 40, which is nice. That's what we wanted. So let's actually change this to fill rect as well, now that we've seen a visual representation of that. And let's change the color to something that isn't black. Let's say, what's a nice color? Light gray. No, that's kind of what it is already. Let's say, I don't want anything that's going to hurt my eyes, so let's just say white for now. Let's see how that looks. Yeah, kind of, that'll be fine for now. That'll be fine. No, let's go grey. Design decisions killing me. Yeah, that's fine. That's okay for now. What I'm also going to do, just while I'm developing here, I'm also going to do a draw rect. Whoops. If we put this in the for loop, so then it always colours them grey, but I just want an outline of the square, just so it's always there. Draw rect. Sorry, g.color first. G.color. Set color. Color.black. And then we can always see the squares then. Again, it's just going to be the same stuff here. And then that way we don't get confused. Now let's just see that on the background there. Yep, there we are. Perfect. Okay, so now we're finished with the background. It's time to move on to the snake itself. Firstly, we need to kind of think about how the snake might be put together. It's not one thing per se, it's multiple blocks all kind of traversing together based on each other. So with that in mind, we're going to create a new Java class, and it is going to be called, we're going to call it body blocks, like so. Maybe refactor that into body block actually, because it's not plural. Body block, there we go. Okay, so if we think about the snake's body, it needs, every block in its body needs a x coordinate. Every single one needs a y coordinate. It also needs a constructor. Let's say body block. And then it's going to take in also a start x and a start y, where it's going to start from. So we will say this dot x equals start x, this dot y equals start y. Cool. We do need to add a couple of getters in here as well, so if we use the generate trick getter and add a couple of those in. Now we need to create the snake object, which will kind of hold all these body blocks and information about that. So let's do that. Let's call it snake. This snake object is going to have a private list of body blocks called body blocks, like so. Let's instantiate that so we don't get null pointer exception, and let's make sure it is the correct one. It is. Okay, cool. We also kind of, in terms of snake, care where its head is, so body block head, simply so we know when it's crashed, when it's hit something like the reward or itself. Next we need a constructor where we're going to instantiate a bunch of stuff. So let's say public snake. It's going to take in a start x, start y, like so. I'm then going to do that, and then what we want to do here is instantiate the head. Set that equal to new body block, start x, start y, and then body blocks dot add head, like so. Finally, what we want to do in here is add a couple of getters for both the head and the body block. So both of those in like so. Now that Snake contains all this information, what we can do is go into Game Engine and set up something in here. So we need to have a snake in Game Engine. So if we do snake like so, we're going to instantiate it via Game Engine's constructor and pass it through from main, simply so we have more control later over how Snake affects the game as a whole. So in here, if we do snake, sorry, I need to pass it through as a parameter first. So snake, and then we can do this dot snake equals snake, like so. One related problem. Where is that? Oh, okay. Is it to do with Snake's constructor? No? Okay, where are you? Okay, yeah, of course. So in here, we need to create a new snake. The start X and the start Y. I'm just going to pick two arbitrary numbers. Make sure they're divisible by your scale, because if they aren't, it will start in the middle of a square, in the middle of two squares, sorry, and you won't be able to get it back. It will just kind of like ride along on that trajectory. And then also, what else did this take in? Nothing, just a start and the end. There we are. Start X and start Y, sorry. There we go. This currently doesn't do anything as of yet. If we click run, nothing will happen. But what we can do, as you can see, what we can do is start drawing the snake now. Now we have the information about the snake, we can start drawing it. So here in Paint, if we go in here and we're drawing if we comment this to say that's the background, and then we can comment here to say snake. It's important that the background is drawn first, and it's drawn in order of what you want to appear at the top gets drawn last in this instance. So here we want to draw the snake, so let's do for body block in body blocks snake.get body blocks. That's better. What we can do is say g.draw or fill rect, and we're gonna make the snake green. So let's do that. Let's make it green. G.fillRect, and then we're going to say block dot get x, block dot get y, and then the width and the height is just your scale number. So here it's 40. Is scale in here? Scale is not in here. Scale is in here. Sorry. Scale and scale, like so. So we should now be able to see this snake that we're drawing. And there he is. Yeah, so again, if you've used an incorrect scale and it's not divisible, it might end up like slightly to the right over two squares and it looks kind of horrible. So that's why we do that. Now we've done that, we can look at making the snake start to move. To start that off, we need to kind of start repainting this background repeatedly, kind of like frames. So to do that, what we're going to do is set a timer up here at the top. The timer will be used to kind of determine how fast we refresh the page. So new timer, timer T, new timer. The delay is in milliseconds, so let's say 100. And that will give us 100 frames per second, and then the listener will be this. With that, we need to also implement an interface here. So we need to implement action listener. What that means is Game Engine can now handle input in a nutshell. Kind of. We can implement a method now from the action listener interface, which allows us to get key events, and we can attach all that up later. But for now, we need to implement this so we can attach the timer to this object. With that, what we can now do in Paint, wherever that's gone, in here, we can say t.start down here. And what that does is, once it's painted it once, it starts the timer and then does it again. So in action performed, we can repaint. So it will just keep doing it repeatedly now. So after 100 milliseconds, when it hits here, wait 100 milliseconds and then it will repaint. So nothing should have changed as of right now. Just to confirm that, we're going to take a quick look. Yep, nothing's changed. It's just going to, you won't be able to see it because the frames per second is quite quick. Clearly, it's just refreshing this page lots and lots and lots of times at the minute. Now we kind of need to work on directions. So when the snake spawns in, it's not currently moving. We need to get it moving in a direction. From where we normally spawn, I'd say down is a pretty good way to go in terms of where we want it to go. So to do that, what we're gonna do is we're gonna go into snake, and in here we are going to create an enum. If you don't know what an enum is, again, take a look at my Java for Complete Beginners. We go through enums, quite interesting. We have up, down, left, oops, left, and right. Then we also want to add in the current direction. So to do that, we have private direction current dir. Let's call it that for now. We also want to instantiate this when we create a snake object. So we can say direction dir, and then we can say this dot dir current dir equals dir, meaning when we create the snake object, if we choose we want to spawn it in the bottom right and make it go left, we can do that by defining these. That's just gives us a bit of flexibility there. Now we're of course getting this problem because we've defined a snake without actually giving it a direction. So we can go in here and go snake direction down. There we are. What that's going to do, if we put that on a new line, what that's going to do is start it off by going down. Currently this doesn't mean anything though, so what we're going to have to do is associate this with something with meaning. And we can do that here in action perform. So every frame that we refresh, we can check to see where the direction is pointing. So in here we're just going to write a if statement regarding that. Yeah, I'll write the first bit and then I will speed up the second bit to kind of get through it. So snake.get current directory. Okay, so we actually don't have that yet. So we need to add that in. Direction again. Just do a getter here. Find usages, refactor. Sorry, generate. Getter current direction. There we go. So if we go back in here, if snake.get current direction, there we go, is equal to snake direction. Why is that doing that? Snake direction down. Then this doesn't exist yet. We're going to create it in just a second. Move down. And that's what we're going to do. We're just going to write an elif statement determining this, and then we'll move on. I will quickly speed up and do that now. Next, we need to implement the methods here that don't exist yet. So let's do that. I will write one and then speed it up again because the other three are going to be the exact same, just different wording. So if we do public void move down like so, and we say bodybox equals move body blocks down, or something along those lines. The thing is, there's a lot of logic in here, so I just want to keep that separate. And then we can in here set the head to bodybox.get 0. It's really complicated, and I want this to be its own function because we're moving the body blocks down, and it's quite a long algorithm. The reason we have to do that is because if we just try and move everything down, you don't get the trailing effect if you're just moving it all down. If you've got like 10 behind that was on a left turn before, then they will just start moving down with you in that shape, and it's not what you're after. It's more like Tetris. but this is this gets you the nice trailing effect. So I'm just going to write 3 more of these. I'm going to speed up and I'll be right back. Okay, so now I'm going to implement one of these methods and do the other 3 the exact same. I'll show you the differences before we move on, so don't worry about that. But the complicated thing about these is, like I said before, you have to get that trailing effect. So let's do that. Let's start with down, shall we? Because that's the way we're going to be going initially. So to do that, we're going to go here and we're going to say public list body block. Move body blocks down. There we go. So what we're going to do is we're going to have a new list of body blocks called new body blocks, like so. Just set that to empty. We're going to populate that in just a second. We need a temp X, so the temporary X get 0. Don't worry, I'll go through this in just a second, so we can understand what's going on. Y get position 0 for get Y, and then a counter as well. All this is saying currently is a brand new list of body blocks that is not yet filled. A temporary X to hold the first, so basically the head's X value and Y value, its coordinates, and we have a counter. Okay, so what we're going to do in here is say for body block block in body blocks, like so. So if it's the first one round, we've got to be careful. So we need to say equal to 0. If it's the first one round, we don't want to do any fancy stuff, basically. So new body blocks dot add. Oops. New body blocks dot add. New body block. Block dot get X. Block dot get Y minus scale. Don't worry, we will go through this in just a second. Oh, scale's not in here. It is in game engine. Not scale. No, can't do it like that. Okay, no problem. We'll just call it 40 and sort that out in just a second. Why is that telling me I'm wrong? Oh, okay, I see. And then there we are. Okay, so I'll finish off this if statement and I can go through the entire thing. So if I just do else, new body blocks dot add new body block temp X temp Y temp X equals block dot get X temp Y equals block dot get Y, and then we want to make sure that's the correct variable name, and then we want to return new body blocks. Okay, let's talk about what this function is doing, because it's a little bit confusing. Okay, that's in the wrong place. Sorry about that. Move that there. It's a little bit confusing if you've not seen anything like this before. So what's happening is we also need to put counter plus plus here, because otherwise counter is never more than 0. Okay, so what we're saying here is we're moving down. So let's first get up Paint to explain this real quick. So if we have our screen like this, oh god, that's a line, that's not a pencil. If we have our screen like this, this is X, this is Y. Okay, when Y increases, we go down. Okay, so Y is 0 here, and X is 0 here also. So X increases as you go this way. So if we're going down, we need to increase Y. We need to increase Y by 40 every time. So if we've got two blocks here, two body blocks, let's say, and this body block is traveling down. So we know the next time it wants to move, it wants to be here. Okay, that's where it's going to. That needs to go there, but this needs to go in the position of the last one. It doesn't need to go down. That's the important difference here. If we could make it just go down and it would work as long as we only ever traveled down, but to get that trailing effect that looks like an actual snake when it does this, and the tail's here and the head is here, and you've got all the body in between, it needs to take the place of the last one it was in. Okay, so how is this doing that? Okay, so it's saying if it's the first one, we're just going to sorry, that needs to be a plus. We're just increasing its y value by the scale, meaning it's moving 1 square forward. Okay, 1 square down. And we know it's the first one because when we move blocks down, the counter's 0. If the counter isn't 0 though, that means it's not the first one. And we've stored the first one's x and y values here. So then the second one, the second time round, what we do is we say, okay, we've got this x and y value here of the first block. We then move this. We then create a new body block where the old one was, with the temp-x temp-y here, and then we set the temp-x temp-y to the one that it's currently on, which is the second one, and so on and so forth. And this ricochets all the way back until every single block has took the one in front of its place. Now this is really simple to replicate for the rest. All we have to do is copy this, paste it 3 times, and change a couple of values. 1, 2, 3. Okay, so we've done down. So we've done down here. Let's do up here. Let's see this. And then if it's going up, remember y needs to decrease, because if we look back here, 0 is at the top. So if we're going up the screen, y is getting lower. So all we need to do is change that to a negative. Left. It's not the y at all. We're now working on the x-axis, going back to our screen here. If we're going left, x is 0 here, x is 1,000,000 here. So we're decreasing, meaning x gets less. So x minus your scale value, mine being 40. And then finally, right is the same but opposite. So it's not on the y, it's on the x, getting positive. And that is everything for moving the body blocks. What we can do now is just have a quick run of that and see what happens. We should be expected to go down the screen. Yes, it is. It does run off the screen and it will continue to do so. But there you go, there's some movement on the screen. Our first movement, we can't actually control it, we can't do anything just yet, but that's okay, we'll get around to that. We have movement on the screen, which is really important. Good. So the next thing to move on to logically is controls. So we currently have a moving block as of right now. We want to be able to control that. So let's try that. Let's go ahead and create a new Java class here. We're going to call it controller. This controller class is going to extend a key adapter, meaning it can read keys in and do something about it. Okay, so we want a snake in here. That's the thing we're going to be controlling. And then we can have a constructor to set that snake up. Controller, snake, the standard this dot snake equals snake. This is going to complain about an unimplemented method, surely. Import class, no, okay. Okay, so what we need to do is use from the key adapter, use this key pressed method. So what we're going to do is we're going to copy and paste that in here, like so. What this is going to do is every time a key is pressed, it will read that and do something about it. So I think an appropriate thing here would be to use a switch statement. So we're going to get the key code and switch on that, basically. Okay, so what we can say is case, There is a list of key codes. If you go in here, let's try and find them. CVK, WPON, etc. You can find all the key codes in here. It's all documented. So you just control click on key code and it will take you straight to that class or that method, this particular method, sorry. And in there you can find all the key codes. I already know what keys I want to use. I want to use WAS and D. So we do key event dot VK underscore W. And that's going to mean we're going up, right? So standard switch statement, here we are. A nice little code block. And if one thing we do have to be careful with is if the snake is traveling down, we can't instantly press up, because if we do that, then we essentially go through ourselves, and we can't do that. So we have to go right or left first and then up. So we can only ever go up if we're not going down. So if snake.getCurrentDirectory is not equal to down, okay, what we're going to do is we're going to say snake.setCurrentDirection. Oh, we don't have a setter for that. Okay. We can do that real quick in here. Direction, current direction here. We'll put it right next to the getter, which should be at the bottom. No, it isn't. Where is it? Get current direction. Get current direction. We can add it right here. We can say generate setter for current direction. Okay, there we are. Set current direction. Here we go. So then we can set its current direction to snake direction dot up is where we want to go, and voila, we now have changed the direction. We need a few of these clearly for the other keys, so we're going to use S for if we're going down, but we can't be going up, so we can't be going up, but we need to go down, and then straightforward A if we want to go left, but we can't be going right, left, and finally D here if we are not going left but we want to go right. There we are. Oh, there we go. We're not quite finished yet. We've still got to add this to the panel. So to do that, we need to go back to the game engine, and in game engine we need to say we need to add a controller in here like so, and then instantiate it. So to instantiate it, all we're going to do is say controller equals new controller and pass in the snake that we're using. And then we also need to add key listener. So add key listener to this panel, which will be controls, and that controller, sorry. And basically that's what that's saying is use this to detect any keys and use its method to determine what happens with them. This should be enough to be able to control the block on our screen now, so let's go ahead and see if that works. Click run. Yep, there we are. I'm pressing, if I press W we go up, S we don't go down. Okay, if it goes off the screen, you've kind of got to get it back on, because we don't actually die yet, so that's pretty cool. But yeah, if I press left, I can't go left. If I'm going right, yeah, that makes sense. Up, I can't go down. You're right. Okay, yeah. So it works. The controls are working how we want them to work. Perfect. Let's X off that. The next thing we have to worry about is the rewards in this game. So the reward at the minute is non-existent. We've also got to think about like what that does when we hit it, but we can do that later when we start thinking about collisions with different things. But for right now, we'd just like to spawn in a reward. So to do that, we are going to create a new Java class, call it reward, call it whatever you want really, coin, apple, whatever worms eat, I don't know. Again, this is going to be like things we've done before. It needs an X value and a Y value, like so, and then we also need a constructor as normal, and this is where we're actually going to instantiate a lot of stuff. We're going to take in a tile list here, and that will be all the possible tiles we can go on, and we're going to see how that works now. So we're going to create a new random, try and generate ourselves a new random number. The pick will be the next integer. The bounds will be tiles.size -1. Again, everything starts at 0. Tile, so the tile which it's going to spawn on is tile picked. Tiles.get at pick index. Okay, cool. What that means is we're creating a new object, a new tile object, and we're calling it tile picked. Let's name that properly. This tile picked will be the one that's picked for the reward. So to set the rewards x and y, we're just going to this.x equals tile picked dot get x chord, this.y dot y equals tile picked get y chord. There we are. This is enough to kind of go ahead and spawn one in. So let's add a couple of getters first, actually, because I know we're going to need to get its x and y eventually. Next thing we need to do is instantiate and draw the reward. So if we go over into Game Engine, in your Game Engine class, if you instantiate the reward by doing reward, go into the constructor here and assign a value. So if we say reward equals new reward, we're going to pass in map tiles, the tiles we worked out earlier, like so. That's going to bug me if that's not capital T, so let me just quickly change all of those. This is going to actually, you could just right click refactor this. It will really bug me if that's not changed though, because it's not right. Okay, map tiles, good. Let's now draw the reward. To do that, we go g.setColor. We want a color for it. I'm going to put mine as red. So color, I'm going to put mine as red, and then we're going to draw it. So g.fillRect reward.getX reward.get y, and our scale amount, which is 40, which is in here, so we can use that. Okay, scale and scale. Cool. Now if we run this, we should be able to see the reward. Yep, there it is. Again, currently nothing happening with it. We're not growing or anything, but it is there, and we are one step closer. The next thing I want to do is add in a pause option, so we can finish off this controller. So to do that, what we need to do is add in a button for it. So if we add in a new case for it right here, and we say case key event we're going to use is the space bar for pausing, space, like so. Add a nice little code block, and then we need to do some logic in here. We then need a variable in Game Engine, a boolean, to say if it is paused or if it is not paused. So public, private static boolean, if I can spell, boolean is paused, set false by default, and then we can add a getter and a setter for that. Let's go to here, the bottom here, generator, generate getter for the boolean. Is paused? No, we'll just take is paused, thank you. And then we can generate a setter also for is paused. Set. We'll call it set paused. Okay. So what that means we can do then is in controls, if we go back to the controller and we say, for example, if Game Engine is paused, then we want to unpause it when we press space, right? So we can say Game Engine dot set pause false, meaning we're unpausing it, and yeah, and then we can say else game engine set paused equals true, just like so. We then need to control the timer, which is in game engine. So we need two more functions. The first one being called pause, and the next one, we'll just do this one first. And all that's going to do is t dot stop, like so. And then public void resume. And then we need to t dot start. And what we can then do in controller, here we need to add in the fact that the particular object, the instance of the object in main, its game engine, needs to, in this instance, if it's paused, it needs to resume. And then the same here, but opposite. So main dot game engine dot pause, like so. So if we just quickly test that now, we are moving around. If I click space, yep, it stops. I click space again, yeah, it starts. Space stop, space starts. Cool. And I'm actually dead here, but I will come back on the screen. There we are. Yeah, works a charm. So pressing space stops and starts. Cool. The next thing we need to work on is collisions. So let's do that. If we go here into game engine, where these collisions are going to be detected is in action performed. So every time there's a frame, we can in here determine what goes on. So firstly, we need to determine what a collision is. So we're going to have three different types of collision. First one is reward being hit, which is a good collision in our eyes, is reward hit. And it's going to take in a snake, and reward, like so. And in here, we are going to just return a statement, snake.getHead. So if the snake's head's x, let's do x first, is equal to the reward's x, and its y is equal to its y. Dot get y is equal to reward dot get y. We're just going to return that. That's the most simple one done. Now onto is a wall hit. It's slightly more complicated, but also not really. We're going to have private boolean is wall hit. It's going to take in a snake, of course, and it's going to say body block current head equals snake dot get head, like so. Return current head. The reason I set that as current head is because this statement gets really long if you don't take that little bit out there and set it as a variable. Is less than 0. So we're saying if the x is less than 0, so it goes off the screen to the left, or current head is dot get y is less than 0, or current head dot get x is greater than window width, or current head dot get y is greater than window height, like so. Now we do have to kind of be careful with these two statements here, because even when it's outside, let me get Paintable to explain this. So if we have the edge of the map here, that's the edge of the map. We have a square here which is inside the map, and a square here outside the map. The start of this square will be the exact window width. Okay, so if this is across, this will be the exact window width where this starts. This will be the exact window width where this ends. So technically, you could end up on the outside of this line here, and your X and Y still be within the window width. So what we should do is make that slightly smaller to say, basically, to account for that, happening. Basically, if you go further, then you're screwed. Basically, that could not happen. So we have to do that. Let's run that, and okay, that's not going to do anything. What am I talking about? The next one is if you hit yourself, which is the most complicated thing. It's not really that bad, but we just need to know if we hit any other part of our body. Is body hit? Snake S. We'll go in here, and we'll say boolean hit equals false. Bar head equals s dot get head. So I'm going to do a nice little for loop here. Int I equals 1. I is less than. The reason we're starting at 1 is because the head will always hit itself. It is at its position always, so we have to start from the second one. So I is less than s dot get body blocks dot size -1, of course, and I++. So that's checking through all the other parts of your body apart from your head. If your head's X is equal to the get body blocks dot get at position I X, and the same for Y, so head dot get Y is equal to get s dot get body blocks dot get at position I dot get Y, like so. Then we say hit equals true, not get, hit equals true. We're going to break there, so if we do break like so, breaks out of that, and then we're just going to return hit at the end, which is fine. Return hit. So if hit ever changes, it returns it, otherwise it returns false. And then what we can do is, in here, like I said before, if we do if is reward hit, like so, snake reward, well, we know score is going to increase, which we don't have yet, but let's make a score. So up here we're going to create an integer called score. Very basic. Set equal to 0. I mean, we can set private as well, and static. Here we are, score plus plus. Going to do snake.grow, which doesn't exist yet, but that gives us a reason to do it. And we are going to do reward dot change location, which also doesn't exist yet, which we are going to do in just a moment. And then again, if is wall hit, or from snake, or is is body hit from the snake, then we just die, right? So we do some death stuff. Do death. We'll handle that later. For now, we care about the reward. So let's do that one first. And yeah, let's figure out how we're going to do snake.grow and change location. So for snake.grow, we have to go back into snake, clearly, and then we need to say, we do it up here, here shall do. If we say public void grow, so what we need to do is we need to take into account the direction it's going, because if it's going left, then we need to add one to the right, if that makes sense, because it really wouldn't. Sorry, we need to add one in front of it, because, or where the reward currently is, because it wouldn't make sense otherwise, right? You get some kind of weird results if you try and add it at the back, going a particular direction based on their head. But let's do that now, and we will talk through it. So we are going to switch, get current direction. and case down, body blocks dot add new body block. So we're just adding a block to our body block set. So head dot get x. So it's going to be the same x, and it's going to be head dot get y plus scale. If it's in here, which it is not, so plus 40. I'm actually going to make a scale in here, probably. Yeah. Let me just finish this, and then I'll do that in a second. Okay, so if we do that, why is this complaining? Oh, okay. Like so. Cool. So in the case that it's down, we're going to add a new body block plus 40 from where we're at, downwards. And if you remember from earlier, if we have the thing and we're going downwards, we're headed down. So this is our dude, and the reward's here. He hits the reward, and then he instantly gets another block there and continues on downwards, like so, by doing plus 40. And then it's just a case of adding all the rest in. Case up, body blocks dot add new body block, head dot get x, head dot get y minus 40, like so. And again, case left, body blocks dot add new body block, head dot get x. So if we're headed left, that means we need minus 40 on that. Minus 4, and then head dot get y, and then add that on the end there. Copy and paste that for the right. So case right, and then plus 40, like so. Next section is changing the location of the reward. So if we go into reward here and we create a new function, if you remember back to game engine, it's called change location. So let's create that function now, and we can say public void change location, like so. It's going to take in a list of tiles because it's going to do pretty much exactly what we did in the constructor. So if we take in a list tiles called tiles, why is that not working? Oh, okay, yeah, tile. So it's going to do pretty much the exact same thing as it did here, and it's just going to redo that. Bang. Okay. That's going to take in map tiles, and voila. With all that, we should have something to be able to look at. Okay, so let's see. We are expecting to grow, which is adding new blocks to us, and we're expecting the reward to change position every time. Let's see if that works. Okay, running. Okay, let's collect this reward. There we are. There we are. Yep, seems to be working just fine. And if I click space, does it still pause? Yes, it does. Cool. So we now have a working reward system. Cool. Yeah, that's working. So now we need to kind of do some kind of death mechanics or lose mechanics. So if we do snake.die, like so, doesn't exist yet. So if we hit a wall or we hit our own body, we're going to die. We're also going to do a J option pane. Now these are like the pop-up boxes. Quite nice to have. Show message dialogue. This score, and then just print out the score pretty much. So what this will do is when we hit a wall and die, or hit ourselves and die, we will then have a pop-up message saying what our score is, which is good. We need to then say the snake is back alive, so we can snake dot is alive. We can set that like that. That doesn't exist yet. We need to create a new snake. New snake 80. 80. So that's where we're starting, and its starting direction is down. Cool. And then we can add some more controls to that snake as well. There's new controls. We just need to redo what's been taken out when we die. Controller, not controls. And then this add key listener controls and set the score back to 0. I keep doing that. Score equals 0. Boom. Okay, so all we need to implement really is when it dies and when it's alive, and what these two mean. Okay, so basically what we need to happen is this needs to be dependent on whether the snake is dead. So if is not snake dot is dead, okay, like so. Surround this in the if statement. So this will only work if the snake is alive. Clearly that doesn't exist yet. It's another thing we're going to have to create in snake in just a moment. But once the snake dies, it sets is dead to true. So this will stop running. This message will then pop up telling you your score. J option pane, show message dialog. The parent component is this, the game engine, and it'll show you score. Then we need to set the snake to being back alive, otherwise it will never start this again. And we need to associate a new controller with it and reset the score also. So quite simply, we need to go to snake, and in here we need to do public void die, like so. And we actually need a couple of variables first. By a couple, I mean exactly one. Private boolean is dead. That's that. We're going to set it to false in the constructor. It's false, just so it's false when we start, which is good. Die, we're going to set it to true. If I can type. Then we need another one called public void is alive, and that is going to set it to false. And then we also need the getter kind of public void, boolean is dead. Return is dead. Cool. So that should sort out anything in here. Cool. So with all that, we should be able to now see it work. So let's take a look. First thing I'm going to do is practice crashing into all the sides. Yep, there's one. There's our score 0. That side. Yep, good. Yep, okay. Cool. All the sides work. Let's see if crashing into ourselves works. Okay. Gonna get a few of these going, and then I'll crash right into myself. So let's do it now. Yep, okay, cool. So the collision works. Cool, awesome. Let's close this off. Okay, we're nearly finished. We're just going to add a few final finishing touches. The first being some colour schemes, which I was showing off in the original kind of intro part. So the first thing we're going to go ahead and do is create a menu bar to allow us to click on those particular colours. So we're going to create a new class. We're going to call it menu bar, and this menu bar is going to extends JMenu, JMenu bar specifically, and it's also going to implement an action listener. Action listener, like so. We're going to implement unimplemented methods. Yep, action performed. Cool, we want that. Awesome. So this menu bar needs a menu, JMenu, and we'll call that menu. Then we will have JMenu, color menu, and then some items in there. This is where you can become a bit creative with your colors. So JMenu item, I'm going to have original, which is whatever we're using now. Dark, light, and retro. Okay, cool. So you can have as many or as little as you want. Again, this is just making it look nice at this point, but it kind of highlights how you'd use menus within Java. Now we're going to create the constructor for our menu bar class, public menu bar, like so. We don't need to take in anything, we're just going to set a bunch of stuff up. So, the menu, so the top left, when we click run, the button is going to be called options. You can call it whatever you like. I think options is fine. File, I sometimes see, but options is okay. Color menu equals new J menu, like so. And then, so this is going to be the button within that button. So you click options, and then there'll be a menu selection called color options. I'm going to use the American spelling because it's the most common, like so. And then in that menu, there are going to be multiple menu items. So original equals new J menu item, and it's just going to be called original, like so. And we're going to do this for dark and light and everything else. J menu item, and that's going to be dark. Same again for light. Light equals new J menu item, light. And then retro is new J menu item, and that's going to be called retro too, like so. Then we need to add listeners to all those buttons. Well, just the color menu buttons. So original dot add action listener this, aka this menu bar. Again, original. Sorry, not original. Dark add action listener this. Light add action listener this. And same for final. It's retro dot add action listener this. Awesome. Then we need to assemble all these things together and add them all together. So menu.add, we're going to add the color menu to that. There we are. And then we're going to do color menu dot add original, and the same for the rest. Color menu dot add dark, color menu dot add light, color menu dot add retro, like so. And then we can add menu, and what that's doing is adding it to this menu bar, which is the class which extends J menu bar. Cool. Okay. So in now action performed, we need to do some stuff. But before we can do that though, we need to define a new class. That new class is going to be called color theme. Java class color theme, and this is just going to allow us to store a bunch of color themes basically. So private color, snake color, so color for the snake. Yes, I do want that one. Private color, we want a reward color, and private color, we want a background color, like so. Cool. We then want a constructor, public color theme, color S, color R for reward, and color B for background. Then we just set them all in here. This dot snake color equals S. This dot reward color equals R. This dot BG color equals B. That's them being instantiated, and we're gonna put in a few getters for these things, and that should be this class done, like so. That's that. This is just going to store colors for us, which is exactly what we need. Now we need like an active color theme here in the game engine. So if we go in here and we do color theme, like so. In fact, we're going to instantiate it now, which we will do the original colors here. So what am I using? I'm using red, green, and grey. Okay, so new color theme. So color theme is, what's this? Color dot, is it the snake first? It is. So red, green, and grey. We're using green for the snake. Color dot red for the reward, and color dot grey for the background. And that is our original color theme. So that's what we're going to put in original. But that way we can now swap out all these. So when we're coloring the background, we need to get rid of this as well, which is the squares. We don't have to. We can keep them in actually for now. Color theme, which is that dot get. What are we getting? We're getting the background color for this. Then here, this is going to be the reward, which I haven't commented, which I will do now. And what we can do in here is say color theme dot get reward color, and again color theme dot get snake color. Awesome. This also needs to be private and static, so we can access it from the menu bar. Private static, there we go. Because there's no game engine instance in the menu bar, so we have to do this statically. That's fine though, because it can be something that's static. It's not necessarily that bad in this instance to do that. So if you do private static void set color theme, we're going to take in a color theme, and we are going to set game engine dot color theme to theme, like so. What we can now do is go back into the menu bar, and in the actions performed here, we can start setting up our very own color themes. So firstly, I'm going to do the original, which is what we're currently using. So if e.getSource is equal to original, and getSource just tells us what button was pressed, as we've labeled it here. So if it was the original button, that means we want the original color scheme. So we're going to do game engine dot set color scheme. Why are you not working? Oh, it's private. 1 second. Make that public. Could make it package protected, but who cares? Set color scheme. New color theme. And we are going to do green. Color dot green. Color dot red. Caps red. And color dot grey is the original. Cool. Then if we do if e.getSource, so I'm going to do 3 more. I'm going to do light. So if e.getSource is equal to light, then we can do something in there and say game engine. Basically the same again. I'm just going to copy and paste this at this point and change the colors and the words. So we've got original, light, dark, and retro. Cool. So light can be white. So this is that is the snake. That is the reward, which we will say is yellow. And we'll have white here. And this can be dark grey. No, maybe grey. Dark grey. Oh, sorry, black. Dark grey. Now I've got some. I tried to match the retro the best I could to how it looks in the kind of old style. So here we have a black snake with a grey reward, and then the colour we can assign new colours. I mean, we don't have to use predefined ones. We can give an RGB here, so we can say I found one earlier that was pretty good, 58 100 20, like so, and that is all our colour schemes done. Finally, we just need to add it to the frame. So if we go into here and we say just here, we do frame dot set chain menu bar to new menu bar. That should be good to go. Next thing I want to do is just tidy up the color a little bit, the background and the snake and stuff. So in here we've got the background. We want to get rid of those black squares. You can keep them if you like. I'm going to get rid of mine. And then we're also going to, on the snake, we're going to, instead of fill rect, we're going to do fill round rect, like so. That is not quite right. Like that. Cool. And then this needs 2 more integers, which is to do with the angle at which it cuts the corners. I use 15 and 10. You can use what you like. That just gives it a nice little rounding there on that. And I think that should be it. Let's take a look. Yeah, awesome. So we've got like a rounded snake there that you can see all its different body blocks. Let's pause and check out our color options. Dark, there we go. Nice. Cool. Let's again pause. Color options, light, nice. Pause, again, retro, awesome. And there you have it. Successfully created a snake game. If we crash, successfully created the snake game, and it's working like it was shown in the intro. Not bad, not even bad. Further on from this project, you could decide to add your own menu options in here to increase the speed, which would change the timer here. You could also change the size by changing the scale option in a setting here. There's some further on tasks for you. But as far as doing the snake game as shown in the intro, that's it. That's everything. I hope you enjoyed this video. I hope you learned something. Hopefully you can follow along with this quite easily. If not, let me know in the comments what I could explain a little bit better, and I'll try and do that. I'm going to increase the complexity of these projects as I go along, so subscribe and stay tuned for the next one. See you later.